whole agriculture in automated with low cost, and also to design a new app called as Farmer Selling Point app, which I'll describe later. So in our research work, we had carried a deep neural network based in interactive fuzzy Bayesian algorithm for designing this system. So by the using this system, we had got an accuracy rate of nearly about 98.7%. I'll next the reduced labor of this is lost system. And next, research objectives. So actually, we had taken 4 different objectives in research work. So for better decision making, as I said earlier, to suppress the global food demand. So better food decision making is needed in an automated system to describe efficient results. And next, cost savings and labor shortage. That is, we need the system to be designed with low cost. So that is the main objective of our research. Next, producing higher yield. That is the crop production level, which increases the production is needed. Next, whenever we design a system, accuracy is more needed there. So accuracy is here needed in a larger level. So these are the 4 main objectives which we are focusing here. Next, what is actually forming in agriculture? Making everything automated. That's making some SaaS robots and in place, making the system automated from the support system. How does artificial intelligence work here in this support system? So this is and by compiling the data, AI will predict. And the third one is gaining high quality out. So here productivity is nothing but after harvesting, we will just examine how much the production we observed. So these 3 features may involve smart farm. And next, getting into the literature survey, actually smart farming technologies have evolved from 2006 in different countries, but by different technologies, they consider different factors. That is, for example, weed detection system, for example, water prediction and precision agriculture, they considered on major factors. And we had here used this smart farming automation system for this production using this DNN-IF-based algorithm. And next, what were the limitations in the existing work? Here in the existing work, as we know, these are all some common factors which we always approach by the previous research work. That is high error rate, high labor cost, and high water or energy consumption, and regular field evaluation. This is the main factor in without automation in agriculture, because the people has to go every day examine the activities in the agriculture field. And next is about the poor efficiency. And next, AI in agriculture. So basically, when we take artificial intelligence in agriculture, we consider 6 major factors there. That is the crop yield prediction, intelligent spraying of seeds, predictive insights, agricultural robots, crop and soil monitoring to direction of the crops, and disease diagnosis in variety of crops depending upon the soil quality also. And here in our proposed methodology, we have used IFBS, that is interactive fuzzy Bayesian search algorithm. Here the first step is data acquisition. So we are using certain cameras, there is 3 different of cameras which will able to be collecting pixels. So here the data is collected and we are experimenting using this melon and sesame plant. So we are taken here 2 different plants for experimentation. Here is melon and sesame plant. And what is IF-based algorithm? I want to describe here. So as fuzzy search, so fuzzy search is nothing but where we use algorithms or strings to match patterns absolutely. For example, if we type in Google in a wrong way, even we will get some predictive results in the right way. So that is nothing but fuzzy matching algorithm. This is a spell checker and a spell error detector to give it predictive results for us. So here we are using fuzzy search and Bayesian search in this IF-based algorithm. Bayesian search is nothing but this will give deduction, that is using probability mechanism. We are getting the exact results. So here there are 5 different steps, analyzing all the possible scenarios, creating a probability distribution, and then making all the probability distribution, examine that and finding the exact search path by using the Bayes theorem. So combining the fuzzy mechanism and the Bayesian mechanism comes the interactive fuzzy Bayesian IFBS algorithm. So here this interactive IFBS algorithm forms both the path, that is this has the search pattern and the interactive search pattern. So in this method, interactive fuzzy Bayesian search works actually. So here we are in the field, we are using both the tracking mechanism and the interactive mechanism using this Bayesian search. Here next, how does deep neural network is involved in this algorithm? So DNN is nothing but is an artificial neural network. That is AN, which contains multiple layers. So this has weights, neurons, and functions. Here by that is what analyzing, that is here the blue circles indicate the crop water stress index, soil humidity, soil pH, soil temperature, and data from the plant. So these data are analyzed and they are examined in the hidden and the connected layers, and we get the exact output by minimizing the error rate. So we are combining the deep neural network along with this IFBS algorithm for disease prediction in this agriculture automation. So here how this is actually the flow diagram of my research work actually, which had currently done. So here the parameters have been examined. So by using the melon and the CCM plant, 20% of the data is given for testing and the 80% is given for training. So we are constructing the neural network accordingly by the testing and training data sets, and we are setting the criteria. And next, what are the materials and methods I had used here is crop water stress index, irrigation treatment, soil quality, and noise filtering, because these factors are mainly considered by when we analyze some data, because the stress of crops vary about different types of crops. Irrigation treatment will also differ because some crops need a less amount of water, some crops may vary. So these features has to be considered. And next, this is pretty from the leaf. So actually, from the pH level of the soil, water irrigation level, and here we are detecting these data, analyzing these data, and finding out the disease crops. And next, so how these soil sensors are placed in the field. This is a model how the soil sensors are placed in the field, analyzing temperature, moisture, pollution, and the direction of pH level in the agriculture field. And next steps in the implementation. Actually, these are 8 different steps which have to be considered. How to inhabit this IF-based algorithm in DNN. So importing the libraries, how to describe data visualization, outlet deduction, label encoding, splitting the data. That is actually these steps are involved. Actually, what I described earlier in the diagram, flow diagram, those steps are actually involved. I had written here, and how the model is built and how the metrics are calculated. And next, going into the performance evaluation. So after completing this model, the performance is being evaluated on AUC analysis, that is area under the ROC curve, cost analysis, accuracy, specificity, and the F measure. And next, comparative results. So here the comparative results, actually after evaluation, after description of the system, we had analyzed and we had plotted the values in 4 different graphs: cost analysis, accuracy, specificity, and F measure graph. So this is the cost analysis comparison graph, which is compared to the previous algorithms, DN, and here accuracy, specificity, and F measure. Actually, we had compared this with the various techniques, artificial neural networks techniques and other techniques. So here our accuracy is 98.7%, specificity and F measure we had obtained higher previously to the next techniques. And next, this is my current work. After this disease prediction and disease examination, I am doing my current research work on crop production. So I had examined, I had collected some data sets and from the Kaggle webs, and I am doing this analysis now. Data set of rainfall in India. And next, this is the overall merged data set. And next, this is the encoded data. And this is the sample application page for finding out the crop field prediction. And this is what I had found. So when this system is automated, agriculture system is automated in overall, so we'll nearly find a higher profit in nearly few years. So concluding this, IFBS not only improves the agriculture system, it makes the whole system automated. And not only that, we are making the system easier, and we are finding a better accuracy here. And these are my reference papers which I had chosen for designing this system. And thank you.
Here from Delhi Technological University, and my topic of discussion for today is efficient net B5 based transfer learning for multi-label classification of diabetic retinopathy using Clahe pre-processing. So the keywords over here is multi-label classification of diabetic retinopathy using Clahe pre-processing and efficient net B5. So I'll be covering these certain aspects in today's presentation, which are motivation, the introduction, the data set which we have used, which is Aptos 2019, the data pre-processing steps which we have done using Clahe, a bit about transfer learning, efficient net B5 architecture, the results, and the conclusion. So diabetes mellitus is a chronic disorder that is rapidly becoming more prevalent in the worldwide in today's world. It is defined by hyperglycemia, which restricts the body's utilization of glucose. Diabetic retinopathy comes in 4 severity levels, which is mild, moderate, severe, and proliferative, which is a frequent side effect of diabetes, which is very common in today's world. It is anticipated that approximately 700 million individuals would suffer from diabetes around the globe. And among those 700 million, 34% are anticipated to be suffering from diabetic retinopathy. Machine learning models can aid in automating the detection process, allowing for early diagnosis and intervention of diabetic retinopathy. The models can be deployed in various healthcare settings, including remote and undeserved areas, enhancing access to screening and improving healthcare quality. These models are implemented so that because in today's world, only ophthalmologists can detect diabetic retinopathy, that too at a severe stage, which ultimately leads to complete vision loss. So now in deep learning, in our study, we have implemented deep learning to categorize the intensity of diabetic retinopathy using neural networks and transfer learning. The Aptos 2019 data set was used in this work. Several pre-processing techniques such as resizing, grayscale conversion, Gaussian blur, thresholding, contour detection, Clahe, and median filtering were applied to improve the picture quality and make it easier for the neural network to understand the lesions in our nerve, in the nerves which are present inside the eye. Convolutional neural networks, primarily efficient net B5 in the study, was used for feature extraction and classification. Finally, we achieved an accuracy of 96.11%. The Aptos 2019 dataset was taken from Kaggle. It is open source. So the dataset consists of pictures of eye, which we refer to as fundus images in our paper. It includes a collection of approximately 3,600 high resolution images. The dataset was very heavy. It was approximately 10 gigabits. A group of trained doctors have divided the images into 5 categories, namely no DIIER, mild DIIER, moderate DIIER, severe DIIER, and proliferative DIIER, named 0 to 4. So it's a labeled dataset primarily. The dataset roughly consists of 1,800 images, which do not possess diabetic retinopathy at all. And the rest of the 1,800 images are classified into 4 different categories. Further, I'll explain a bit about data preprocessing and the Clahe steps which we have implemented. For that, I'll explain what Clahe primarily is. So Clahe stands for contrast limited adaptive histogram equalization. Histogram equalization is basically a technique used to enhance the contrast of the image. But in histogram equalization, we come across over brightness in the images, which reduces the clarity of the image, due to which researchers take into consideration adaptive histogram equalization. Now, adaptive histogram equalization broadens the noise in the image and it over amplifies the noise in relative to the homogeneous regions of the image. Hence, we come across contrast limited adaptive histogram equalization, which is Clahe, which limits the contrast amplification to reduce the noise amplification. Thus, it performs histogram equalization in small patches with high accuracy and contrast limiting. So the pre-processing steps which we have used are, firstly, we have transformed the image into grayscale and Gaussian blur is applied, which is further followed by thresholding to eliminate the black background resulting in a binary image. Subsequently, contour detection is applied in order to obtain a cropped image. Now, the cropped image was converted to a lab color scale color spacing, and the L channel in the lab color spacing was adjusted using Clahe. Furthermore, the image quality, to improve the image quality and to diminish the noise, median filtering was applied. In order to extract the blood vessels, we subtracted the first median. We applied 2 different median filters in our data preprocessing. The first median filter was subtracted from the second median blurred image in order to extract the blood vessels. Finally, a bitwise AND operation was performed to remove any blood vessels in the image and establish a uniform background. So this is the example. This is an example of the original image which was obtained from the Aptos 2019 dataset, and the image which we have obtained after pre-processing. We can see it explicitly, the differences between the two. Now I'll give a brief overview about what transfer learning exactly is, because we have implemented EfficientNet B5, which is a transfer learning architecture. Transfer learning makes use of information and representations acquired during pre-training on a separate but related task in place of creating a model from start for a new task. In this case, we have taken use of EfficientNet B5 architecture, which was pre-trained on ImageNet dataset. The learned representations are preserved by first freezing the parameters and weights of the pre-trained models. The pre-trained model is covered with a fresh set of layers. These extra layers are then trained using the new dataset, particularly for the new job, which is Aptos 2019 in our study. Now, EfficientNet B5 offers 7 versions, it was formulated by Google AI. So it is made up of variety of layers, namely max pooling layer, batch normalization layer, and convolutional layers. The combination of layers and modules within the EfficientNet B5 architecture enables the extraction of highly informative features for the image classification, which is fundus images in our case. So EfficientNet B5 is a very big architecture. It's a very big neural network, which consists of approximately 28 million parameters, trainable parameters. This is the architecture of EfficientNet B5. So the module 1 consists of convolutional layer followed by batch normalization and activation layer. And these are the 5 modules which are a part of EfficientNet B5. The image on the right shows the architecture of the EfficientNet B5, which includes an array of these modules which form the complete architecture of EfficientNet B5. Now we'll come to the results and discussions part of our research. We achieved an accuracy of 96.11% with a loss minimization of under 0.08%, which can be seen in the images shown below. The better performance shown here depicts the very much first condition of effectiveness of the algorithm, which is EfficientNet B5. When we compared the time complexity of our models over the others, we saw drastic differences between the two. To give a rough overview of the same, the classification task, the multi-label classification tasks achieved an accuracy of approximately 93% on the Aptos 2019 dataset, whereas we achieved an accuracy of 96.11%. So to conclude, we presented an efficient convolutional neural network architecture, EfficientNet B5, preceded by Clahe enhancement to categorize diabetic retinopathy severity levels. We have achieved an accuracy of 96.11% on the Aptos 2019 dataset, and our results show that the pre-trained model architecture EfficientNet B5 surpasses other techniques for THEIER severity classification. Now, when it comes to the future scope involves utilizing of this technique on additional datasets of varying sizes to investigate how performance fluctuates with changes in the dataset volume. We can also implement EfficientNet B5 and Clahe to diagnose different diseases such as cataract, bulging eye, and glaucoma. Thank you. So you're muted.
Myself, PNVS Pawan Kumar, Assistant Professor, Department of CSE, G. Polarity Engineering College, and I am going to present on smart video surveillance system for vehicle crash detection. Yeah. So here, first, I need to talk on the abstract that is presented. So here, road accidents is a very serious and high priority public health concern. And the statistics shows more than 1.25 million people die each year as a result of this road crashes. So here the different risk factors are there for this road accidents because of speed, more speed, drunken drive, no safety equipments used, and distracted driving, unsafe vehicle, and law enforcement, and more importantly, there is no inadequate and more importantly, inadequate post-crash emergency care because of post-crash emergency care. So here, any delay in this detecting of these factors and providing emergency care is not provided, and can lead to the increasing of severity in the accident. So that is the reason why we are working on this. The advancement in the fields of this artificial intelligence, machine learning, and deep learning, we're able to make our device more smarter and smarter. So here we are presenting a paper with the idea of implementing statistical method of deep learning to detect any kind of a collision in a live field, the application of convolution neural network. So here we build an intelligent traffic monitoring system using the state-of-the-art deep learning models that aims to detect traffic accidents, burning vehicles using a single model for real-time monitoring purpose using CNN, simple transfer learning. So here we use the method of simple transfer learning for easy training. So here start the literature survey, a method for traffic collision detection requires usually 3 steps that we found in survey. So that is detecting vehicles. First thing is we need to detect vehicles by using certain methods like frame difference method and the edge detection technology that are used in the survey. Next step is vehicle tracking. So once you detect vehicles, vehicle tracking is needed. So this can be done by matching the distance, area, and histogram of the same vehicle. Next frame can be used. And the next thing is vehicle collision detection can be done. Here the concept of collision area and key point as a pre-qualification and prior knowledge and histogram information is used. Next, video-based traffic accident analysis at intersections using partial vehicle trajectories. The research mainly proposes a new technique here, and that is extracting abnormal event characteristics at intersections of the vehicles. That is, learning normal traffic flow using trajectory clustering techniques, then analyzing accident events by observing some partial vehicle trajectories and motion characteristics. There are 3 phases in this approach. One is the model to model. One is it implements video pre-processing, vehicle detection, and tracking in order to extract vehicle characteristics and road intersections. Second phase in this model is to determine motion patterns by implementing trajectory analysis and then differentiating normal and abnormal events by defining descriptors. And the last phase executes semantic decisions about traffic events and accident characteristics. So these are the various phases of this approach. So the classification in this research work, there are various classification methods that work on this accident detection in the literature. So one of such is SVM, which gets accuracy 89%, artificial neural networks 90%. So we in this paper presented random forest approach, okay, which achieved 91%. So which is found to be more better, which is showing better performance when compared to that of SVM and ANN. So here traffic accident detection using random forest classifier. The system uses simulated data collected from the vehicular ad hoc networks based on the speeds and coordinates of the vehicles. and then it sends traffic alerts to the drivers. Next, it shows how machine learning methods can be exploited to detect accidents on previous in ITS. And it's shown that if position and velocity values of every vehicle are given, vehicle's behavior could be analyzed and accidents can be detected easily. So that is why the position of the vehicle and velocity values of the every vehicle should be known, and vehicle behavior can be easily analyzed with these parameters. So that is what we concentrated in this algorithm. So here the proposed algorithm is the administrator starts surveillance and he checks the connection, continuously capture images, and he compares these images especially. Okay, and so here the captured images are continuously compared the standard image, and if the intrusion is detected, then it is a notification is sent, and the videos are frequently recorded. So that is it. So in the literature, like where proposed a new prediction model of traffic accident black spots based on GA-BP neural network algorithm and upset theory. So to evaluate these traffic accidents quantitatively, Hideki Fuzzy had developed a cognitive error model and implemented it into the multi-agent based traffic simulator. And in this system, we are using a CNN with a simple transfer learning for detecting vehicles. So for the detection of collision. So this approach is giving a more better performance than the previous approaches which is observed there. Okay. The transfer learning, what is transfer learning? Is the reuse of a pre-trained model on a new problem is known as transfer learning in machine learning. So that means the already pre-trained model is used, and its output is used as input for the new model. Okay, such that the time is saved and efforts are also saved. So a machine uses the knowledge learned from a prior assignment to increase prediction about a new task in transfer learning. The knowledge gained while learning to drive a motor vehicle can be used to some extent when learning to drive a car. So initially, this is a good example where we can use the transfer learning. So the knowledge gained by learning to drive a motorcycle is used as the input to the learning of to some extent to learn to drive a car. So there's no need to acquire knowledge of everything from scratch and trying to learn something new. So that is the purpose of transfer learning. So that approach we are using here. In computer vision, neural networks typically aim to detect edges in the first layer, forms in the middle layer, and task-specific features in the latter layers. So here in the training, this transfer learning, the early and central layers are employed in transfer learning, okay, and the latter layers are only retrained. So we need not again develop this early and central layers for every model. So it makes use of the labeled data from the task it was trained on. So that is the purpose of this transfer learning. So how this works means here the pre-trained model will be there. So this pre-trained model is already having the layers of input and middle layers and the latter layers for classification or the model method. The next common inner layers, this input layer and the middle layers are used as a common inner layers for the custom model, and the final layers are tuned as per our requirement. So that is how the training layer transfer learning works. So using transfer learning approach, an application can be easily created to process a task that involves adjusting pre-trained model. First, it is started with choosing an existing network like Google Net, and new data is fed into that architecture. After making some small adjustments to architecture, and application that can perform a new task can be produced. This is what is called as transfer learning. Here, we also use the convolution neural network. The transfer learning offers a number of advantages, most important of which are reduced training time, improved neural network performance in most circumstances, the absence of large amount of data. Yes, sir. The algorithm used in deep learning approach using CNN architecture implemented in a MATLAB version. Here, the convolutional neural network is being chosen as it is more suitable for pattern recognition. So CNN structure is made up of 3 blocks of batch normalization. It's also included following layers like a convolution layer with a ReLU activation, dense layers and pooling layers, max pooling and soft pooling. The convolution kernel size was decreased and the pooling window size was increased while maintaining the same number of kernels for each block in the single architecture. So this is the results of our work. The accuracy of our model got 80% accuracy and precision is 78%, which is looking pretty good. And recall is 70%. Sorry, recall is 63, which is good for this model as it's above 0.5, and F1 score is 70%. So in this way, we build the model and we are trying to improve that further. Thank you. These are the various references we use. Thank you very much.
So I'm Praveen Barbutia, and I say, good afternoon to everyone. I'm at the University of Wisconsin, and I want to share my research on ethical climates and unethical pro-organizational behaviors. Looking at what everybody else has been talking about today, clearly, I'm one of the few social scientists, so please bear with me. So the focus of the paper is on unethical pro-organizational behavior. So these are behaviors that employees engage in companies that help the company, but it's also unethical. And so there's lots of interest to try to understand what explains that, because it has some benefits for the company, but it can also be a problem. And one good example is the Volkswagen diesel emission scandal. I don't know how many of you remember that. Basically, they were fudging the software so that they could show that the trucks or the cars that they were selling wasn't polluting as much. And so what did we want to do? We wanted to explain how ethical climates in companies are antecedents of unethical pro-organizational behavior. As I was saying earlier, it is necessary for us to try to understand how, why that happens and what are the factors that explain that. And what we did was we looked at one aspect of the organizational component, which is ethical climate. And ethical climate basically is defined as the shared perception of what is morally correct behavior and how ethical situations should be handled in an organization. And so we are trying to understand the gap that exists. And as I was saying, ethical climates are very important components of that. So we basically have 5 hypotheses, and I won't get into the details, but basically the ethical climate has 9 different dimensions, but empirical kind of test has shown the existence of only 5. And so we have basically hypothesis built around each of these 5. And the instrumental is basically where people are egoist. Caring is when people are more benevolent. Independence is people who follow rules and so on. And role is also something that has to do with like the kind of, organizational codes of conduct and so on. And so we say that if you're in a situation where people care for each other, then there would be a negative relationship to unethical pro-organizational behavior. And then if it's people are caring, then it will be supportive because people want to help the company. And then if you have independence or rules, climate, and so on, as you can see, we have different hypotheses here. So we basically, my co-author who's mentioned on that paper, Silan Wang, he is in China and he was able to get 976 employees from many companies in 6 provinces. and the measures we used were the ones accepted in the literature. We used ethical climate questionnaire. The UBP was measured by 6-item scale. And one example was, if it would help my organization, I would misrepresent the truth to make my organization look good. And so here are the results. After we ran the regression model, we found that instrumental was positively related to unethical pro-organizational behavior, while principal local cosmopolitan was negatively related. And the other hypothesis was not supported. As you can see, caring and independence did not have any relationship. And so we were surprised. Instrumental climate was supposed to have a negative relationship. But again, the instrumental climate is one where people are being egoist, and it is very possible that also encourages them to do things to help the company. But we did find support for the principal climate, no support for the caring climate. In any way, in any case, we find that this makes some significant contributions to the literature. First of all, it responds to the call to explore antecedents of that, and also clarifies the relationship between ethical climate and unethical pro-organizational behavior. It also shows that, we did the study in China, and there hasn't been much done in China. And also it helps provide better explanation of unethical organizational behavior. Thank you so much for your attention.
So I'll again
Yeah,
start
yeah.
with the presentation outline. I'll start with the introduction. So access control is the process which decides who is authorized to have what particular communication rights on which particular object with respect to some security models and policies. So basically the access control mechanism which aims to prevent the illegal resource access from the unauthorized entity. So only the authorized user should be able to grant the permission for particular resources like IoT devices, files, and the sensor. So as shown in the figure, this is the simple IoT structures where all the IoT devices which are connected through the gateway to the peer-to-peer system, peer-to-peer network, and in the same way, all the storage devices and servers which are connected with the peer-to-peer network. Here we can see that there are 3 different types of architecture. First one is a centralized architecture. So in the centralized architecture, all the data which are maintained in a single computer or in a single server. Whereas in a distributed architecture, this is like a single logical data network, but they are connected, all the nodes which are connected to provide the integrity and accessibility of the information. Whereas in the decentralization, in decentralized architecture, different data, other resources, and the processing power which are shared among all the nodes within the network. There are few challenges in the healthcare system. First one is like a lightweight. So as we know that different patients which are nowadays wearing some sensors, some devices which can monitor the health vitals. So they will not store large amount of data. So lightweight devices is the biggest issue in terms of storage and retrieving the data. Scalability, when we are going to store and retrieve the large amount of data of patient, at that time scalability is the major concern. Another one is a centralized architecture. So as we know that in the centralized architecture, all the data which are stored at one location or one server, where sometimes it can be a performance bottleneck or single point of failure. And the last one is the privacy. So when we are going to share patients' information, sometimes some of the patients' informations which are private, personal, so only the authorized person like doctor, nurses, and some pharmaceutical companies or some other persons who are authorized, only they can show the information. So these are the challenges in the healthcare system. For that, there are so many different access control methods are there. By applying the different access control methods, we can overcome all these issues. Start with the discretionary access based access control. So in the DAC, data owner or some administrators who can determine who can access a particular data items. In the mandatory access control system, where the hierarchical security structures which are defined for access rights. Third one is attribute-based access control. So in the attribute-based access control, particular access rights which are defined based on a set of attributes like some user's name, age, gender, object, some locations, particular time, etc. Whereas in the rule-based access control, we are not directly giving the access rights to the users, rather than we are just creating the rule first, and in that particular rule, we are assigning the rights, and then after we are giving the rule to the users. And the last one is the capability-based access control mechanisms. So that in the capability-based access control, the access rights which are going to provide to the legitimate users based on the capability. And here capability is in terms of token, in terms of key, or in terms of one-time password. So we can share the particular token, password, or a key for accessing the particular data or the information. And for that, blockchain technology are used. So here, as shown in the figure, these are the different blocks which are created and all the blocks which are connected. So first of all, we need to understand what is blockchain technology. So blockchain technology which are developed to address and some of the limitations of the centralized system. So basically, blockchain is a distributed ledger which enables the peer-to-peer network and allows the data to be distributed publicly, and which provides trust, security, and transparency of each and every transaction. So as shown in the figure, it shows with the block header. So basically block header which identify a particular blocks. Then after the previous hash, so which is used previous hash and the current hash. So basically previous hash and current hash which are used to connect the two different blocks. Another data which contained in the block, that is a timestamp. So when a transaction is occurred, it will stored with the timestamps. And the last one is the Merkle root tree. So basically it store all the transactions in the block of data by creating a different digital fingerprints of the entire transaction. So as shown in the figure, how the blockchain works. So as we can see that first of all, whenever any user will go for the transaction, so it will send the transaction request. Then after the transaction has been created, and then after that can be broadcast to every node in the network. So basically in the blockchain, there are so many different nodes, and all the nodes, they are sharing the same information. So that transaction will be broadcast within the network. After that, if each and every node will validate the transaction, and if all the nodes which are agree, then and then new block will be created, and then after that block will be added to the already there is a already created blockchain. So new block will be added to the blockchain, and then after the transaction will be complete. Here I have done the literature survey based on the different access control methods for the healthcare records, and here I'll show you the research which are already done by the different researchers. So as shown in the figure, as shown over here, the access control policy algorithm for improving the data accessibility between the healthcare providers for the healthcare systems, where the access control policy which are generated based on the Hyperledger Fabric. So basically the Hyperledger Fabric is a particular platform for blockchain technology. So all the smart contracts and all the chain codes which are developed using the Hyperledger and Ethereum network. In the same way, in this paper, discretionary access control method is used, and here the major contributions are based on the access control model, which provides interoperability for the different health records. In the same way, here the access control list which are generated to achieve a flexible access control, as well as how we can revoke the particular access rights from the users, as well as we are going to provide the tempered proof of data, because basically the blockchain will provide the tempered proof data. So because whenever we are going to create a new block, all the informations which are stored in the blockchain in the form of transactions. So no one will be able to tamper the data. In the same way, in this paper, the blockchain-based cloud storage with using the capability and attributes-based encryption. So here the capability which are generated in terms of token, and for providing the privacy of users' data, attribute-based encryption are used. And the same framework which which is already implemented using the Java technology. So in this paper, the author has proposed a blockchain-based access control for the e-healthcare system by applying the role-based access control. So that in the role-based access control, they have already generated the different roles and different rights for the users, and then after it will be applicable for the other users. Next one is the blockchain-based access control system with incentive mechanism for the e-healthcare system, patient as a supervisor. So here, author have used the hybrid mode to achieve the scalability for the large number of users, as well as for providing the security of electronic healthcare records by applying the Hyperledger framework within the network. And this one is the BSSMD, a fine-grained secure sharing scheme of medical data based on the blockchain. And for that, the fine-grained medical data sharing are used, applying the attribute-based access control for the Ethereum network. These are the few research directions. First one is the scalability. So when we are going to provide the large number of users and we are going to provide the large number of data to the system, we can go with the scalability. Another one is the privacy. So in privacy, whenever we are going to share any user's personal and private information, we can achieve the privacy. Another one is the decentralization and access control. So these research directions which are found. And the last one is the conclusion. So in this presentation, the challenges of access control system which are identified, and based on that, the literature survey has been done with using the blockchain technology. And in the last, blockchain technology for distributed platform which works without the use of trusted third party could be encouraging paradigm for security services of the different access control mechanism. These are the references.
I would like to thank you all. I would like to thank you to give me an opportunity to present my work. Myself, Nakiba Shaukat, I am an ME student in Department of Electronics and Communication of UIT Punjab University, Chandigarh. I'm here to present my research, which is denoising of underwater images using mechanism of pressure retina and bilateral filter. These are my contents. First of all, introduction. First of all, denoising is a process to remove noise for underwater images in order to get fine visibility and genuine appearance of an underwater image. Now, why denoising is needed? It is actually used for a complete monitoring of underwater scenery, and it's needed in the areas where the quality of underwater image is decreased by the influence on the surrounding medium. The primary challenges faced by the underwater image are brought on by light absorption and light scattering when light rays passes through the water, which results in horrible visual look, noise, and degraded edge quality of an underwater image. So therefore, to obtain high quality underwater images, these difficulties actually must be overcome so that underwater images be accurately analyzed in order to gain a deeper understanding of the underwater environment and marine life. Next is absorption and scattering of light in water. When light travels through water, it is greatly harmed by absorption and scattering. Absorption is actually a wavelength dependent parameter, and it increases as the depth of the water increases, resulting in red light, which is of longer wavelength, being more absorbed than the remaining wavelengths. On the other hand, scattering happens when light strikes the water particles and its direction of propagation change, resulting in light not being reflected from the desired underwater objects towards the camera. So due to absorption and scattering effects, underwater photos suffer from undesirable blurring, noise, and degraded edge qualities. This is the previous work. In the first paper, to increase the visibility of the underwater objects that are located far from the camera, and Kuti have actually proposed a strategy based on the principle of fusion that works as an excellent edge preservation and noise reduction technique. But this technique is not able to deal with the image taken under artificial light source. In the second paper, actually the traditional denoising methods are not able to remove the backscattered noise and even causes more distortion. So in the second paper, Zhang uses two algorithms, that is non-local means algorithm and block matching 3D filtering, to counter the back scatter noise in underwater images in order to get better image quality. But the disadvantage of these algorithms are they are not able to preserve the edges of an underwater image. In the next paper, which is actually presented by and Kuti, two techniques are used, that is void balancing and fusion. As one goes down deep inside the water, the greenish bluish tone dominates. So to rectify it, void balancing technique has been used. After that, a multi-skin fusion strategy is used to preserve edges and details of scenes affected by scattering. But the disadvantage is that there is some haze left in the regions that are located far from the camera. In the next paper, which is proposed by Jan and Wen, explains how laser propagates in water and discuss how noise in underwater images can be removed by using a variety of filtering techniques. And it has been determined that wavelength threshold filtering technique effectively removes noise and does edge preservation of underwater images with a short runtime. The next paper here actually a UD and net, a GAN-based network has been actually proposed by Zhang. It consists of a generator network that improves noisy images into the clear images, and a discriminator which distinguish between the images produced by the generator and the reference image, and does so in order to increase the production of noise-free image from the generator. The next paper, which is presented by Gao, actually present a method based on how teleospatial retina works to improve contrast and details while also correcting the color of an underwater image. The next paper is presented by, actually proposed by Lee, which actually proposed an underwater image enhancement benchmark, which contains a total of 950 underwater images, 890 of which had unique reference images. Reference image here are created using the preceding procedures and are compared to find the best one with reduced noise level and enhanced edges. But the disadvantage of this technique is that there is always a problem of backscatter. And the next paper which is present by Lu, he actually proposed an MLFC GAN network. In this network, the local features of the degraded image are actually merged with the global features on different scales, resulting in reduced noise levels and maintaining edges of a degraded underwater image. But its disadvantage is that the noisy patches are produced. Next paper, in the next paper, a traditional unambiguous filter called the guided filter has been proposed by he. It performs edge preserving smoothing operator and has a good behavior near the edges. But also its computational complexity is independent on the filtering kernel size. It has noise removal, detail enhancement, as well as smoothing. In the next paper, various filtering technique has been proposed by Lu to do the noise reduction and to enhance the global contrast, as well as preserving the edge of an underwater image. Now, motivation. Light in the water is scattered and absorbed as it travels towards the camera. So scattering and absorption are a big hindrance in getting a good quality images. These issues are independent of each other and results in degraded image quality. So it is necessary to resolve these issues together in order to get a good quality image. Next, objectives. Actually, the images captured in water are often blurry with noise, degraded edge quality, degraded structural details due to the issues of scattering and absorption. So here I proposed a technique for underwater image enhancement on MATLAB R2015A image processing tool using mechanism of fish retina and bilateral filter, which actually acts as a smoothing filter and does detail enhancement, edge preservation, as well as noise reduction. My aim is to increase PSNR, decrease MSC, decrease MA, and increase the SSIM for an underwater image. Now, background study. As we know that underwater environment appears blurry to the humans as our eyes do not have the ability to perceive the underwater environment clearly because of high refractive index of water. On the other hand, fish's eye can see underwater environment clearly because of their spherical lens. So here I'm using the mechanism of fish retina and bilateral filter to remove noise and preserve edges of an underwater image. First of all, here comes fish retina. Fish retina consists of photoreceptors, horizontal cell, bipolar cells, ganglion cells. When light actually strikes the photoreceptors, it starts a series of actions that aid in the transmission of visual signals across the retina. Photoreceptors are further classified as rods and cones. These photoreceptors then transmit the signals to the on-center and the off-center bipolar cells. Next, the bipolar cells are connected to the rods and the cones have inhibitory and excitatory response to each other. Then there comes ganglion cells that carry the visual information from the bipolar cells, which eventually leave the eye through the optic disc. Here are also horizontal cells which actually receive the signals from the surrounding photoreceptors, make change in the signals, which are then transferred to the bipolar cells. Then comes bilateral filter. A bilateral filter actually utilizes nonlinear functions to enhance the image quality by reducing noise levels and maintaining the edges of an underwater image. An underwater image actually contains a lot of edges, so it can be a very good example to preserve edges and do noise reduction. Since pixel intensities fluctuate greatly at the edges, so this filter takes these variable intensities into account to preserve the edges in the underwater images. This filter replaces the value of a particular pixel with the weighted average value of the surrounding pixels. Now, this is my research methodology. Actually, I have proposed a hybrid technique, which is a combination of fish retinal mechanism and bilateral filter. Here, I have taken two scenarios. In the scenario one, when light falls on the central photoreceptors, it gets hyperpolarized as a result of decrease in the release of the neurotransmitter. The on-center bipolar cell then gets depolarized due to reduction in the release of the neurotransmitter from the photoreceptors. Then the on-center bipolar cells is going to release more neurotransmitter on the on-center off-center ganglion cells, which in turn get excited. And hence gets depolarized. That results in the increase of action potential taken towards the brain. So in the case of off-center bipolar cells, it gets hyperpolarized and it is going to release less neurotransmitter on off-center on-center ganglion cells, which gets inhibited and hence get hyperpolarized. That results in decrease of action potential taken towards the brain. Here are also horizontal cells, which are actually the inhibitory cells. They receive the signals from surrounding photoreceptors and integrate them and makes change in the signals, which are then transferred to the bipolar cells and also sends an inhibitory signals to the central photoreceptors that prevents them from releasing the neurotransmitter. Also, they rectify the non-uniform biasing of colors in the cone encoded signals. Now, in the scenario second, when light does not fall on the central photoreceptor, it gets depolarized as a result of increase in the release of the neurotransmitter. The on-center bipolar cells gets hyperpolarized here due to increase in the release of neurotransmitter from the photoreceptors. Then the on-center bipolar cells releases less neurotransmitter on the on-center off-center ganglion cells, which in turn gets inhibited and hence get hyperpolarized. That results in the decrease of action potential taken towards the brain. Here, the off-center bipolar cell is depolarized and is going to release less and it's going to release more neurotransmitter on the off-center on-center ganglion cells, which in turn gets excited and hence get depolarized. Also, which in turn which results actually in the increase of action potential taken towards the brain. After that, the responses of on-center off-center ganglion cells and off-center on-center ganglion cells are combined to get the enhanced image. However, the edges of the underwater image are not well preserved. So to preserve the edges and to remove the noise, we will use here a bilateral filter in both the scenarios, which gives a smoother appearance to an underwater image by removing noise and doing edge preservation simultaneously. So it does this by joining the darken tone levels based on photometric similarity and mathematical proximity between them. Here also the special weights and range weights are multiplied with each other to get the final enhanced image. Next, experimental results and discussions. Actually, the methodologies which I have used to measure and access the underwater image qualities are PSNR, MSE, MEE, and SSI. First of all, PSNR, which stands for peak signal to noise ratio. It is actually used to measure the quality between the two images, that is the reference image and the reconstructed image. More PSNR, better will be the image quality. Next comes MSE, which means mean squared error. MSE is the intensity difference, or we can say cumulative squared error between the reference image and the reconstructed image. The intensity difference here is actually the difference in the pixel values between the reference and the reconstructed image. Lower MSE, better will be the image quality. Next comes MAE, which means mean absolute error. It measures the average error between the reconstructed image and the high quality reference image, but cannot predict large errors. The lower MAE, better will be the image quality. Next comes structural similarity. SSIM means structural similarity index matrix. So it evaluates how closely the reconstructed image resembles the clear high quality ground truth image. Its value actually falls between -1 to +1. More SSIM, more will be the quality of image. And now there is a comparison of approach of the 4 underwater images. So the results which I have acquired using my combined approach of fish retinal mechanism and bilateral filter for the 4 sample image were discovered to be better, as shown in these figures as well as in this table. So therefore, we can conclude that this combined approach improves the underwater image quality more. Additionally, as shown in this figure, this combined approach actually preserves edge and eliminates noise more effectively than the previous approaches. Next comes conclusion. The primary problems that affect the underwater image quality are light absorption and light scattering when light rays travel through the water, which results in underwater image having poor visibility, degraded edges, and noise. So it is necessary to implement the algorithms that can overcome these challenges. My approach, this combined approach of fish retinal mechanism and bilateral filter, improves image quality more by doing edge preservation, noise reduction, smoothing, and remove the undesirable artifacts in an underwater image. These are my references. Thank you.